So welcome back to the third episode in a series where I'm doing a major rebuild of my CNC3018. In this episode, I am working on the linear bearing rods that go under the bed. The hardware that I purchased for mounting the rods really don't have an easy way to accurately locate them on the frame itself. And it also looks pretty susceptible to some type of movement, so I'm not really happy with just using that as a solution. The original rods actually have holes drilled into the ends of them and they've been tapped, and that both locates the rods in relation to the frame and also fixes them to the frame. But the screws are pretty small and it seems like a pretty weak fixture, and the screw heads actually had eaten into the surface of the original frame, so I'm not really liking that as a solution either. In the case of the 12mm rods that I newly purchased, the ends are actually pretty roughly finished and they don't have any screw holes, and they're not even cut to an exact length, so there's problems all around there. Anyway, my idea is to combine both of these types of mounting solutions, and hopefully that will give me the best accuracy and the maximum possible holding force and rigidity. But to do that, I'm going to have to machine and tap the ends of the new rods. And as I said in the prior episodes, I have a big list of things to make with the mini-lathe for this CNC project. So in this episode, I'll be making some custom bolts to actually go into those tapped holes. I've designed them to have a really large head, so hopefully that will distribute the securing load. And they also have a very accurately sized and rather long shank that will help locate the rod and the frame panel together. And once I've got those rods secured in place with these bolts, I will then provide some additional support by fixing the rod support hardware that I've newly purchased. Anyway, let's get started. So I'm using a 20mm diameter piece of steel stock that I have here. I think it's called Sum 23 in Japan here. That's the largest size material I can actually fit on my mini lathe that actually passed through the headstock there. And I have to use this 4-jaw chuck because that's the only thing that allows this 20mm material to pass through. My 3-jaw I think only allows about 15mm to pass through. So you see me here trying to get it all centered. I usually do that by looking at the extremes and then continually tightening down on alternate sides to target that halfway point between the extremes. It looks like I'm pretty good. So around about 1/100 of a mil right now should be good enough for this. I'm not going to use the cross slide for cutting this, and I'm not using auto feed either. I'm not using auto feed because I'm a bit worried about slamming into the chuck there. And I'm also looking for really the ideal sort of feed speed. Sometimes I find that the auto feed's a little bit too quick and it gives a rougher and nastier finish than I'd like. I'm not going to use the cross slide because obviously setting up the angle accurately is always problematic. And there's also the issue is as you get more stick out on the cross slide, it gets susceptible to leverage basically, and it actually will cut with the pressure of the cutting surface on the material. Will actually push out a little bit, actually change the diameter. So really I'm only going to use that cross slide on very shallow cuts where it's not going to have much chance to make any noticeable error. So there's the finished cut. And yeah, I'm going to go for 14mm. I know the original design was 13, but I decided to make it a bit bigger. Why not? Got the material. Just clean it up here and we'll take a final measurement and see how we got. Yeah, about 3.5 of a mil over, which is fine for a screw head. I think nobody's going to care about that. So I'm not using that cross slide, so I don't have any way to sort of indicate or accurately judge the distance. So I'm just going to measure it here and then do a marking cut. And then I'll just manually cut to that position. There's quite a lot of material to remove, so I'm going to get a bit aggressive here and just cut down a bit. And then when I get down low enough, I'll take a reference measurement so I can then zone in on that final size. Yeah, a bit over 8mm, so got a bit more to go yet, but anyway, that's the starting point there, I guess. Should be getting close now. So 5/19.5. It's pretty good. That's going to be good for getting it right on the button there. Hopefully this will be the final cut, and I'll do the facing inside cut here as well, or at it. Tidy that up. Well, just a little bit more to go, 4.5 hundredths over. And 0.5 hundredths over. Yeah, well, we'll get a bit of emery cloth or sandpaper in here, and that should just knock that off hopefully. You don't want to get too aggressive because you can lose a couple of hundredths of a mil pretty quickly here if you're not careful. Yeah, 0.5 hundredth under. So yeah, I think that's pretty good. I think I can live with that. I'm just going to mark the length of the thread that we want to cut in here. Bit of black pen and just scratch it on there. And I'm just going to drop down the diameter in that zone where we're going to cut the thread to the specification required. It's basically nothing. It's probably not even needed, but I just do it anyway. Look at these chips that have come off here. I mean, they're so robust. So the mini-lathe's done a pretty good job of cutting this steel without a problem, that's for sure. And I'll just knock the corner off here so that we can start cutting the thread a bit easier with the die. Yeah, looks pretty good. And before I started actually making this bolt, I'd already done this bit of work here, which is making a die holder, which I can mount in my pail stock. I'm just finishing off here and back polishing that, but yeah, it's just a pretty tricky little bit of work, but it came out really nice. Shame I didn't record it actually, but it's quite an interesting little project, but I guess it's not really that related, so anyway, here it is, and there's the die, and you can see it's a pretty tight fit, which is what we want, and yep, just right, looks good. I also added a grub screw there to finally lock it in and locate the die in place. Yeah, really pretty. I like this. So I've got the die holder and the die in the collet there mounted, and I'm just manually turning it. Now I've got the mini lathe still turned on, so the ESC actually locks the brake on, which is making it hard to turn on. There we go. It's off now, so now I can freehand it. And it's not too difficult, it's pretty good. Yeah, it's looking really good, I like that. I'll just do a bit of a fit check, make sure that the thread is doing its job. Pretty tight at the end there, but I think that's fine. Just knock the sharp edges off here. I clearly couldn't have been bothered getting out the bevel tool for this little bit, so anyway, I probably should have got it out, but it is what it is. Just knock off any sharp edges with the emery cloth here. All done, looking good. Now for parting, it's parting off really anything, any material is my nemesis really, I think. Maybe brass I can do pretty painlessly, but steel is a bit of a challenge. You can see I'm using that little tool support device there, which I've adjusted. And this totally changed my life. I actually got this by a recommended video from YouTube, I don't know, it sort of popped out just before I did this bit of parting work. And I can't remember the name of this guy's channel, so I feel terrible. If I remember it, I'll stick it in the comments, but something about cats in his videos. But anyway, he suggested making this support, and it was a little bit more in depth. He had suggested that you needed to drill and tap out the hole underneath the tool, but mine already had it already drilled and tapped, so I didn't need to do that. And he also talked about having an exact size. I think that's a mistake, because as you can see here, I've finally made an adjustment to get the height just right to cut the center here. Now if this exact size was used, I can guarantee you it's never going to be exact all the time. The tools are going to vary and things are going to vary, so having it screwed in and adjustable, or having a bit of, you know, a millimeter's worth of space there for adjustment makes all the difference. That's where it goes in there, and just as simple as that. It's just a screw which I've cut off and fitted in there. And here's the parted off bit, ugly as ever, but yeah, not too bad. It's not a total mess. So we'll just face off the screw here. I hate those little center nubs, they always stick out there. Go really slow at the end bit there. Yeah, it's got it. And I just use this tool here to shape the head. I was thinking different ways of doing this, but this is what I finally decided on. I had this tool on hand, and I thought it might work okay. So I'm really pushing it right to the point where it starts to chatter. Right there. Even though it's making a bit of noise, it actually doesn't leave any chatter on the surface, or nothing that I can see anyway. So yeah, that works pretty good. And I think it looks pretty good too. Just polish it up a bit before I take it out. Yeah, really nice. Really happy with that. So the next tricky thing is cutting the slot in the head. Now, I made this little plastic jig which you can fit on here, and I'll hammer it home. Obviously hammer it way too many times, but anyway, got to be sure, right? I also put a bit of tape on the blade here so I can sort of judge the height as I'm cutting. And yeah, here we go. Come on. I reckon this blade's pretty blunt, but God, this is dramatic, isn't it? There we go. Yeah, I think I moved around a little bit when I started the cut. Well, yeah, it looks alright. We'll just knock a few of those burrs off the edges there. Using my jeweler's files. I reckon that should just about. Just about do it, yeah. Next up is to heat it up and drop it in some oil. Now, I'm actually doing this hardening process with an eye of trying to minimize the speed of the corrosion, because apparently hardened steel corrodes at a slower rate than unhardened steel. But obviously it's nice to have a bit more strength in there as well, I guess. As long as it's not too brittle, it should be pretty good. So I just bring it up to red hot. This torch is a little bit underwhelming with its power, but eventually it'll get there. And I want to dunk it in quickly, but I'm a bit scared of splashing myself, but yeah, it's a bit too slow. But anyway, you get the point. So this is a bit of old motorcycle fork oil I was using, but it's probably not the best choice. I probably would prefer to use motor oil, which I think I'll use next time. But yeah, you can see the result is quite pretty. The interesting thing about its finish is that sometimes it's a durable finish, and I'll just leave it with that sort of oil baked on coating. But you know, 50% of the time I also get this sort of result. You can see how it sort of bubbles off the face and chips, and that was the case with these screws. And I really can't figure out any rhyme or reason to why sometimes it's really, you know, quite a durable finish as is. Sometimes I'm not. Maybe the oil heats up, or maybe something wrong with the way I'm heating, but who knows. But anyway, in this case, one of them's a disaster, so I decided just to clean off all of that black surface with a bit of emery cloth and use this drill here. Yeah, I reckon that'll do. And you can see there's two that I've made here, and they're looking pretty good. I need to make another two, but I'm obviously going to do that off camera. So that's the unfinished end of the 12mm linear bearing rods that I've purchased. And we've got to somehow get that screw to go in the end here. Also need to cut it to length. As you can see, it's just a little bit over length. I didn't have any copper material or anything else, shim material on hand, so I'm using a bit of aluminium to tape on there and hopefully provide a bit of protection to the rod. I want to scratch up the surface of that linear rod. I also have these spacer here, which I'm using to plug in the back side of the mini lathe hole so that it sort of holds its center while it's rotating, so it doesn't waggle around while I'm doing the machining. Looks about 1/100 of a mil. If I get it under 1/100 of a mil, you know, I think that's about as good as I'm going to get it with this mini lathe. I don't think that's good enough for what I'm doing here. So, that's looking really quite good. So, yeah, that'll do the job. I'm also going to replace to a new insert because cutting this material is really, really difficult. The surface, I'm assuming, is case hardened, and you'll really see it while we're cutting here. Let's take a look. You can just hear it, right? Hammer is shaking the tool around everywhere. Just won't cut in easily. As we get to the center of the material, you can clearly see it's a lot softer. It just cuts, you know, really quite easily there. And that's really going to affect the finish as well, because you're going to have a really sort of resistive hard cut at the outer edge, and then we're effectively going to be diving in as the tool relieves of that sort of hardened pressure. So it means you're going to have to cut very slowly. Chamfer the edge off there the best I can, but it's going to sort of raise up the edges, so I have to knock those down with a file and a bit of emery just to finish it off. I reckon that's about as good as I'm going to get it. Oh God, get on there. Alright, we'll center cut the hole here. So my idea is to obviously create the centering and locating hole, but also want to cut the chamfer. So we'll cut a little bit deeper than I really need to. The chamfer for the hole basically, so I don't have to cut it again later. Oh, actually I think I cut that a little bit too deep, but anyway, here's what it is. Should do the job. We'll cut the hole for tapping. You can see things are pretty stable. Things are not waggling around. There's no sort of run out or movement, so I feel I'm pretty confident we're getting a good centered cut here. I'm not sure if it's a good habit or a bad habit, but I'm always sticking that bit of masking tape on my bits and things that I'm cutting with to cut the length, but quite often you'll see material get bogged under that lip of the masking tape, and it sort of can sort of mess up your drilling operations a bit here. And here I'm cutting the accurate 5mm hole, which is for locating the pin, so the pin will locate both in the frame and in the rod. And yeah, you can see how that tape is now not being that helpful. Anyway, should do the job. The tapping, so I have the first stage tap in there. And here we go. Now everyone can watch me snap off a tap. So I've just got the tailstock sitting free there on the bed, and I'm applying some slight pressure on the back of it while I'm rotating it. And at some point it just pulls itself in once you've got it started anyway, so you can just let it run. And of course, always good to go about a turn in and a half turn back and chop off and break your threads. And yeah, I think that's about it. Now, how's this for Japan, right? My air gun says kinky on it. Kinky Japan. Only in Japan. Blow it out and we'll do the finish cut. There's an intermediate step as well, but I just skip it in this case. I'm too lazy. There shouldn't be too much to cut here anyway. So. That should finish it out. You can see I've screwed this screw into another rod at an earlier stage, but see, here we go. So the panel, the laminated panel or the frame panel that I've created is actually 12 millimeters thick, so it should be pretty close to that. I'm not really tightening the screw down very heavily here, but 12.7, yeah, you know, probably a half more crank on the thread there will lock it into the 12 mil, no problems. And you can see that even though I haven't really cranked it down there at the stage, when I spin it up, it doesn't seem to have any sort of huge amount of run out. So I think we're looking pretty good. So that's the finished result. I reckon it looks pretty good, except for the fact that I've slightly overcut that chamfer. And the surface finish, yeah, doesn't look like I've damaged it, so that's pretty good as well. I also checked that I've trimmed it exactly to length, and I think the best to my ability, it's pretty much spot on. So yeah, there you have it. Not major progress, but I reckon it's pretty important progress all the same. Sorry I can't actually show you everything assembled because there's still plenty more that I need to do before I can actually get to the assembling phase of things. For the next episode, I will be continuing on with doing some more work with the mini lathe. Possibly I will combine a couple of the things I need to make into the same episode to try to keep the episode count down a bit. I guess I'll see how this video does, if the algorithm likes it or hates it. Either way, I hope you've enjoyed, and I do hope to catch you in the next one. So, I'll see you then.